Hello everyone, and welcome to Quantum Queries. On today's episode, we got a fax from Dave, who asks, how do quantum computers work? Well, Dave, I gotta say, you've come to the right place, so let me explain. Electrons are weird. So weird that they take logic and completely throw it out the window to do its own thing, which is why they can be really confusing to a lot of people. However, we can manipulate them in clever ways to use them to our advantage. The best example of this is quantum computing. Computers that we see today use what are called bits, which inhabit one of two states, 0 and 1. The more bits you have, the more possibilities of zeros and ones you have. Millions of these bits are squeezed into each computer, which enables it to calculate all sorts of different things. However, as technology advances and gets smaller and smaller, we are rapidly approaching the physical limit of how small they can get. Enter qubits, or quantum bits. When we look at a picture of a quantum computer, very little space is actually occupied by these qubits. Most of what you see is cooling, which is necessary because of how easily these qubits can be interfered with. To prevent too much unwanted action, these qubits are kept at nearly 0 degrees Kelvin, or absolute zero. Electrons have their own magnetic field, with poles that act kind of like a compass with the Earth's magnetic field. When the electron is in its natural state, that is, spin down, it is classified as 0, or off. When these electrons are energized to spin up, it is classified as 1, or on. Just to prove how funky electrons are, electrons actually point in every direction at once. Only once we observe it does the electron choose one or the other. Where computers would need an n number of bits to complete a request, meaning the addition of computing power is linear, quantum computers need 2 to the power of n number of bits, indicating a exponential growth. So, something that takes, for example, 64 bits will only take 8 qubits, because 2 to the power of 8 is 64. In another quantum phenomenon that I don't have time for today, known as quantum entanglement, observing an electron will alter the electrons around it. For example, if I observe one and it is classified as 1, then one next to it will automatically become 0. This instantaneous action is what makes quantum computers so fast. Quantum computers are not always faster than regular computers though, but they can solve enormous problems with loads of variables exponentially faster. Take the traveling salesman problem, for example. In this problem, created in 1930, a salesman must figure out the quickest way to travel to a bunch of different cities while starting and ending at the same one. While a traditional computer would try every single possible route one by one to find the fastest one, quantum computers would, simply put, test every possible combination at once to find the quickest route. Well, not really, but explaining it would be a whole other can of worms. While they will never fully replace traditional computing, they have many advantages that warrant their existence. There are so many other insane uses of this technology, so I highly recommend you dive into your own Wikipedia— oh wait, that's not out yet. Netscape wormhole on your Windows 98 personal computer. Thanks everybody for watching, and tune in for the next episode of Quantum Queries. Oh, well, what's this? We just got a new fax, and it looks like it's from my producer. Quantum Queries has been cancelled? Oh, well, never mind then.